All right, we'll try this again. So, what we did on Thursday was we were turning a situation into a table and a table into a graph. What we're going to focus on today is we're going to be translating from an equation to a table and then that table into a graph. So very similar to what we did on Thursday. The key difference is we're going to start with an equation this time around. We're also going to be looking at some special features of our graph. And we'll talk a little bit about symmetry as well. You guys have heard that term before, right? Symmetry. Things that are symmetric. All right. So let's get into it. Our notes are in the packet as usual. And I know we already did a warm-up as a class, but I would like to have you warm up your skills for order of operations. So if you guys could find the page that says 1.1.3, investigating the graphs of quadratic functions, and go ahead and do this thing up here first. Please make sure you're following order of operations. That's PEMDAS. And get me a single number for this. So parentheses, exponents, multiplication, division go together, addition and subtraction go together. Take a moment right now. I need you to do this. So the first thing's parentheses. The only thing that's in parentheses are those -3s, but there's only like one thing, so you can skip parentheses. Your next thing you should be doing is your exponent. So go ahead and take care of that exponent of 2. That exponent of 2 means to multiply -3 times itself. Guys, I need you to put your calculators down and work this out by hand, please. We're practicing doing order of operations. The calculator is for if you run into some bigger numbers that you're not sure. If you have to multiply 17 times 13 and you don't know what that is in your head. So the first thing you should be doing here is this exponent. That exponent's on the -3. Everything else should stay the same. The only thing that's going to change is you're going to do that exponent. What is -3 squared? What do you get if you multiply -3 times itself? +9 or -9? I mean, disregarding that negative out there. -3 times -3 is +9. So that'll turn into a 9. We got some addition, we got some subtraction, and we've got some multiplication going. What comes next? The addition, subtraction, the multiplication. After exponent, we got to do the multiplication. So go ahead and do the multiplication right now on your page. If it helps you to underline it, go ahead and do that. But do that 6 times the -3. Write it down underneath it. Bring everything else down. And then finish it off. Come on, guys. Let's do this. Let's do this. Six times -3 is -18. So make sure that there's a minus there. Bring down your -5. Those parentheses aren't doing anything, so I'm going to bring down that as a -9. All that's left now is subtraction, so just subtract from left to right. -9 -18 -5. See if you can do it in your head. If you can't, use your calculator. -9 -18, I want to say that's -27. Minus another 5 would be what? -32. All right. You guys feeling good about that first problem? If the answer is yes, I got great news for you. You're going to do this and it's going to go really quickly for you because you're going to do it a whole bunch of times. If the answer is no, I got great news for you. You're about to get a ton of practice of doing exactly this, because what we're going to do right now is for each of the rows on this table, we're going to do one of these problems. This is why I was trying to get you guys to move quickly here, because if you can't work quickly through this, this is going to take you all day. So here's the big idea for today. If I give you an equation that looks like this, and I ask you to make a table The way you make your table is you take all these x values and you put them in for the x's in your equation. We have already put one x value into our equation. Notice that this equation matches the work that we did up here. What x value did we put in for our equation already? When we did this work up here, what was the x value that I replaced this x and this x with? We already did the work for -3. Can you see that? We got our answer of -32. Well, let's put -32 down here. We already did this one. All right, we've got a few more to do, 12 to be precise. Which x value would you guys like to do next? Should we just start at the top and do -6? Yeah, let's do it. Okay. So can you guys follow along with me, please? I need everybody writing this down. So next to this, or wherever you've got some space, I am going to copy down my equation, but I am going to leave out all of my x's. In place of those x's, I'm putting some blank parentheses, just like I did there. Can I get everybody to write that down exactly like I just did right there? So that is the exact same as this equation. It is just missing this x and this x. And in place of those, I've got a blank spot. And what do you suppose we're going to put into that blank spot? Well, whatever x value we want. You guys said we were going to start at the top, so I'm going with -6. And then we just need to work this out, get a number, and we'll be good to go. Now, every time you do this, you're going to get a little bit more efficient because we already figured out what order we needed to do stuff in when we did that warm-up. So let's do this. The negative is going to stay. I'm going to do that square first. So what do I get when I square -6? -6 times -6 would be +36. All right, and then when we did this before, we multiplied next. 6 times -6 is -36. I'm going to go ahead and drop my parentheses out here. They're not really doing anything. And then we just need to wrap it up. -36 minus 36 minus 5. If you're not sure, you could do that on your calculator. Or if you can do it in your head, even better. -36 minus 36 minus 5 is -77. All right, we're going to do this again. I'm going to have you do several of these by hand, and then I'm going to show you how to use the calculator to do it. Okay. But you need to be able to pull these off by hand. So when we do this on our first test, there's going to be a couple problems where I say specifically, show your work by hand, and I'm going to need to see that you can do it without the calculator. You'll still have a calculator in front of you so you can check your work as you go. So let's practice this again. Let's do -5. So start the same way we did just a minute ago. Start by rewriting your equation. It's the same equation we've been using. -x squared plus 6x minus 5. Except this time, what are we putting in place of the x? Well, let's do -5. I mean, we could put any one of these in there. We don't have to go in order. All right, go ahead and do the same steps again. And then I need you to move on to -4. So I'm going to pause here for a minute. I'm going to come around and give you guys some help. I need to see you working through this. If you're not sure what you're doing, get my attention so I can help you out. All right, folks, I'd love to get your attention back because I want to show you how you can make this go a little bit faster. I need you to be able to do this by hand. Like I said on the test, there will be a couple problems where I specifically ask you to show, plugging -5 into this equation by hand and showing your steps. But there's a faster way. And if you have a scientific calculator, did you grab a calculator yet? Are there none over there? Why don't you grab one, because I want you to be able to try this. So could you guys get your calculators out, please? And please pay attention up on the screen. I want to show you how you can make your life much easier. Now, some of you have some slightly different calculators, but you can do this too, and the button presses are just a little tiny bit different. So I'll come over and help anybody that's got a different calculator here in a minute, okay? See if you can figure out how to do it on yours. It'll probably be very similar. All right. So I'm going to type this into my calculator. This is the one that you guys were just working on. Now, when you use these calculators, there's a separate negative button and a minus button. Do you guys see the two? Okay. Check on your calculator. You probably got a negative button down at the bottom and a minus button on the side. So the negative button is for this, like this is going to be a negative, this is going to be a negative, but this is going to be a minus. It's kind of confusing. You're going to figure out like when to use what. So, but let's go ahead and type this in. So start with the negative button. Hit your negative, and then your parentheses. And then inside the parentheses is a -5. Are you guys typing this in? And then the parentheses close. Now, some of you are going to have a square button on your calculator like this. It says x squared, and you could use that. Or, please don't miss this, if you have a different exponent, look up here, guys. If you have a different exponent, or any exponent, you can use this button. If I hit this button and then put a 2, that's the same thing as saying squared. Okay. And then I'm going to do +6, parentheses, and put my -5 in there, and then at the end a -5. It should look like that, and when you hit enter, it should say -60, which is what I hope you guys got when you did it by hand. If anybody's not getting their calculator to say -60, can you please let me know and I can help you through? All right. Now this next step's gonna, did you type that in? Can I see? Yeah, that's great. And you know how to go back up to here and hit enter and bring it, oh. So if you do second, how do you do it on this? Oh, you just go back up to here. And you can edit it right there. Yeah, thank you. Okay, guys, don't miss this, okay? Because this is the best part of this. Anybody having trouble getting -60 to pop up? Can I get everybody to look up here, please? This is going to save you so much time if you pay attention to me right now. You guys with me? I see people who are not looking at the screen. It's making me nervous. All right. Check it out. When I want to go and do -4, I do not have to type this whole thing in again. All I need to do is go back and change these -5s into -4s. This is going to save me a ton of time. The way you do that is you use this arrow key to move up to that until it's highlighted. Now, on some of yours, it's not going to highlight. It's not going to highlight it. You're just going to get a cursor back on that same line, and you can edit right there. For the rest of us, we've got to hit enter to bring it back in. And now we can use our arrow keys and go over and change the 5s into 4s. Didn't have to type the whole thing in again. Just change those 5s into 4s, hit enter, boom, -45. And then I can go back up and highlight, hit enter, and change the -4s into -3s. Hit enter. -32. I don't know why I did that. We've already done that one. You guys get the idea? This makes it go way faster for you. All right. So I'm going to go ahead and fill in the rest of my table here. Go ahead and practice doing that a little bit. And then let's make sure we've got our table filled out. If anybody is interested, if you've got... for these ones, you can actually make it fill the table out for you. Question? We're about to go over that in just a minute. Yeah, passes available. right. Where's my X? Hey, thank you. I have forgotten how to do this. I'll use this one. Now, at some point, those of you who are going on to some higher level math, you're going to get one of these calculators, and you can actually just type in the equation. So I'm cheating a little bit here, and it'll actually tell you what everything in the table is. So, and you can just copy them down. So I'm going to do that right now, and then I'll have you guys get the rest of the table copied down as well, so that we can carry on with the rest of our problem here. So. Okay, could I get everybody to get the rest of their table just copied off of my screen here? We know how to do it by hand. We know how to do it using the calculator. We're going to practice that in just a moment. But go ahead and just copy off of my screen for right now. And then if you would, please plot those points. Now, some of these points you're not going to be able to graph, like any negative 77, that's way too low. My y-axis only goes down to negative 10. So the first one I'm actually going to be able to graph is, gosh, I think the first one I can even graph is this one, isn't it? But you should be able to graph from here to here. So graph those points for me, please. Do not connect them just yet. There's a special way that we need to connect these. All right, let's do this. 0, negative 5, 1, 0, 2, 3, 3, 4, 4, 3. When you get your points plotted, go ahead and check against mine. Make any corrections that you need to. Let me know if you have any questions. Got those plotted? Are they kind of in an upside down U shape? They should be. We talked about this on Friday. Does this data appear to be linear? Does it fall into a straight line? No, it's more of a curve, isn't it? So when we connect our dots, we want to connect it with a nice smooth curve. So I'm not the greatest artist in the world, so I'll have some wiggles in here. Some of you guys are much more talented than me when it comes to drawing stuff. But connected to a nice smooth curve. Now, does the graph stop right here? Or would it keep going down? It definitely keeps going down, right? Because we can see on our table that, like, if I could, I would be graphing like negative 3, negative 32, which is way down below the bottom of this graph. So let's make a little arrow coming off of the end of there all the way to the edge of the graph and draw an arrowhead on it to tell us that the graph would continue to go down there. Now, we don't have anything in our table to back it up, but would you guess that if you continued doing points in your table that this side would also continue to keep getting more and more negative? I'll tell you yes that it would. So that's also going to continue to go down. All right, so we took an equation. We put numbers into the equation, that gave us a table. We plotted the points in our table, that gave us our graph. Any questions up to here? We're going to wrap this up now with the analysis piece. All right, so here we go. Line of symmetry. So you guys nodded earlier when I asked you if you knew what symmetry was. Can you spot a line of symmetry? If you were to fold this thing over, can you kind of see where it would fold onto itself? What do you think? No? Yes? A couple people are shaking their heads yes. There is a fold. I could get this point to fold over onto this one. I could get this to fold over onto here. I could get this to fold over onto here. Now these aren't even, but remember they would both keep going down forever and ever. So this doesn't look symmetric because like it's a little imbalanced, right? But if we imagine them going down forever and ever, they would. The line of symmetry would be this line right here. Go ahead and draw that dashed line in and let's label that. I'm just going to write up here, line of symmetry. The line of symmetry. There's some other things that we're going to find. They're all listed down below there. So the next thing on our list is x-intercepts. Do you all know how to find an x-intercept? Do you know where the x-axis is? The x-axis is this one, right? It's actually labeled on this graph, so the x-axis is right here. Can you find any points where our graph is crossing or touching the x-axis? You see where it's intersecting? Are you seeing two places where it's intersecting the x-axis? There are. There's one right here, and there's one right here. And we're going to label those x-intercepts. I'm going to put this off to the side. I'm just going to write x-int. And I'm going to draw a little line to these two things. And I'm going to write the x-intercepts down as ordered pairs. This x-intercept is at, well, I'll tell you this one, then you tell me the other one. This one is at 1, 0. And then I'm also going to write the other one down. Can you find me the coordinates of my other x-intercept here? I'll give you a hint. It's going to be something, 0, because x-intercepts are always something, 0. This other one, I can't read it, but it's between 4 and 6. That's 5, 0. Is that what you guys had? Here's a fun question for you. Ponder this for a moment, if you would. Every x-intercept you're going to see for the rest of your math career is going to have a 0 for the y-coordinate. Why is that? Why do x-intercepts always have a 0 for the y-coordinate? Just think about it for a second. I'm not asking anybody to say the answer out loud. I'm actually not even going to tell you what the answer is. But I want you to think about it. Why is the x-intercept always going to have a 0 in this spot? All right, next thing on your list, I can't see it on my screen, but you guys can see it down below. What's the next thing on our list? After x-intercepts, we got y-intercept. Y-intercept. Can you find there's only one y-intercept on this graph? Can you find it and circle it? The y-axis is this one that's going up and down. Do you see where the graph's crossing the y-axis? That's our y-intercept. Find that, circle it. Let's label it y-int. And let's write down the coordinates of that. The y-intercept. Spoiler alert, there's going to be a 0 in this one as well. The y-intercept also has a 0 in its coordinates, always. It's just in a different spot. And for those of you who are inclined, again, I challenge you to think about why Why is it that every single y-intercept you're ever going to see in mathematics will always have a 0 in this spot? Why is that true? All right, we got our x-intercepts, we got our y-intercepts. Next up is vertex. A vertex is a specific point for a type of graph. This graph is called a parabola. If you guys could circle that. A parabola is kind of this U shape. Sometimes they open downwards like this. It's like an upside down U. A lot of times they're going to open upwards too. So this is a parabola, and a parabola has a vertex. The vertex is kind of the place where the thing turns around. Sort of does a U-turn and starts heading the other direction. So this point right here is going to be our vertex. Let's write the coordinates for that point. The vertex could have a 0 in it, or it could not. Sometimes it does, sometimes it doesn't. This one does not have a 0 for either of its coordinates. All right, we're almost done with our analysis. Next up is maximum. Maximum. So the maximum is the highest point on the graph. The highest point on the graph. There's no point that's any higher than that. Can you spot that? Have we already labeled it? We have, yeah. So this point is also the max. I'm just going to write max here. And I'm not going to write the coordinates again because it's the exact same thing. So we got our vertex, we got our max. Last thing is the minimum. The maximum is the highest point on the graph. The minimum is the lowest point on the graph. This is a bit of a trick question. What is the minimum? What is the lowest point on this parabola? What's the lowest point? Anybody want to make a guess? I'm telling you, it's a trick question. The answer is not a number. Ooh, I like that. I like that. What were you going to say? Okay, so I heard two things. I heard infinity and I heard there is no minimum. And both of those are great answers. So I would say if they asked me on this, I would just say there is no minimum. These arrows right here are showing us this graph is going to keep going down forever and ever and ever. So any point you pick on here, there's going to be a point that's lower than that. It's going to keep going below. So we could see either no minimum, or we could say that the minimum is at, now you've heard of infinity before, right? Did you know there's a thing called negative infinity also? Negative infinity is like if you go down forever and ever and ever. Positive infinity would be up forever and ever and ever. So I would either say there's no minimum or the minimum is at negative infinity. You guys have seen the infinity symbol before, right? You know what it means? Can you ever get to infinity? All right. We're going to practice this a little bit more on Wednesday. Wednesday's a half day, so we won't be doing anything new. I'm going to have you do the next page on Wednesday. But we've only got 15 minutes left today, less than that, 12 minutes. So I'm going to start you on our assignment.